Hi, this is Sarah. I want to explain the question number 2 of homework 2. In this question, we have a channel which is noisy, and when we send a zero signal or one signal, with some probability, an error may happen and the signal may change. Okay, let's go through the question. In the part A, we want to find the probability of x2 equal to 1. Okay, based on the Bayes rule, we can write it. We can let me. We can write it like this. We can make it a conditional probability over the space of x1, and we should include the uh, two values and two events that can happen to x1. So we write the probability of x2 equals to 1 given x1 equals to 0, and then we should write it for x1 equal to 1 as well. So we can cover all the uh, options for x1. And we have all these probabilities in the question so that we can multiply that, and that's totally fine. In the B part, we want the probability of x3 equal to 1. So here we should again use the Bayes rule, and we can write the conditional probabilities for x2. I mean, we write the probability of x3 given x2. But here we don't have the probability of x2 equal to 0. We actually calculated the probability of x2 equal to 1 in the previous part, but we should calculate the probability of x2 equal to 0. And as you may see, I have calculated this and I have used it in my answer. And again, this question is similar to the previous one. The B part is similar to the A part. The only difference is that we are now talking about x3, and we should make it a conditional probability over x2. Okay, let's go to the C part. In part C, we have written the probability of x1 equal to 0 given the probability of x3 given x3 equals to 1. Okay, in this part, we need to uh, change this probability so that we can uh, write down the answer. What do I mean is this, that we have the probability of x1 given x3, but we want to make it vice versa. We want to have the probability of x3 given x1. And actually here between x3 and x1 we have x2. So we want to include x2 in our probability. So I will write it down like this, that again, we can, based on Bayes rule, we can add x2 into this probability, and we should cover the two options for x2. Okay, so I have written this like that, and then I will make it conditional. So probability of x3 equals to 1 given x2 and x1. Uh, but as you may have noticed, as you may have seen, we don't need, uh, we can omit the x1 from this probability for because the probability of x3 given x2 is enough, and it's independent from x1, so that we can omit it and we can write it like what I've written in this form. And then when you make the probability of x3 conditional to x2, then from the previous part you have sorry, from the question, you have this probability and you can write it down. And here I have written it down, and this is the answer. Okay, let's go to the toughest part of this question, which is the part D. And we want to, uh, let me, okay. In part D, the question gets harder because want we want to go to the step n, and we want to calculate the limit. Uh, as Professor Chen told us in the classroom, we can also write down this transit like in the matrix form. So we will write the transition matrix, and then we can uh, make it. We can write it to the power of n. But it is not easy to uh, it's not easy to solve this, because you should multiply this matrix for n times, and n is infinity. So from the linear algebra, we know that we can factorize this matrix. So from the factorizing, I mean that you can write this matrix uh, you can factorize this matrix to its eigenvectors and the diagonal matrix that contains the eigenvalues. So I have factorized this matrix, and I have the eigenvalues here, and then I calculate and write the eigenvectors. And here you've seen that. You have seen, here you can see the factorized matrix. And now if and now it's very easily to make it to the power of n, and the two matrices in the right side and the left side that include the eigenvectors, we don't do anything for them, and the power is just going to uh, the middle matrix, which has the eigenvalues. So if so, now we have this, and we can make it to the power of n. And if we get the limit from this, 1 to the power of n is 1, and a number which is less than 1 is going to be 0. So I have write it here, and then I should multiply this matrix with the matrix here, which has the probability of x1 equal to 1 and the probability of x1 equal to 0. Actually, one of them, you will use one of these, and that's uh, going to be, and then we will get to our answer. Uh, um, Thank you.